Let's take a look now at a couple more rules and then another example. It says y limits at a point might not exist. A limit would not exist at a point C if it approaches the left and the right do not equal one another, which we just saw in the last problem. We saw that 3a, I believe it was. And we wouldn't have a limit if the graph would increase or decrease without bound. That means it approaches infinity, either from the left or the right. Finally, if it oscillates between two fixed values, we might not have a limit as well. So let's take an example here. This first graph, as you can see on the left side of it here, if you wanted to just graph this, the f of x here would be 1 over x minus 2 quantity squared. I'm going to leave and just get to a blank Desmos. So I just deleted those extra letters. Okay, so this graph would be f of x equals 1 over the quantity x minus 2 squared. That quantity squared. Okay, so there's our graph. Since it's approaching infinity from the left and the right, we would say the limit itself does not exist. So the left-hand limit, I'm going to call this one, they called it y here, the limit of y as x approaches 2 from the left side would equal positive infinity. The limit of y as x approach 2 from the right side would equal positive infinity. But because they're increasing without bound, we would still say the limit of y at 2 itself does not exist. Why, you might ask? The reason it doesn't is because the graph itself increases without bound on both sides of the x value, the domain value. Because it increases without bound, if it just increased without bound on one side, it still would not exist. It's just the fact that it increased on both sides without bound, meaning it's going to infinity on both sides, just doubles over that it does not exist. Okay, so this limit would not exist. And I kind of realize that it's kind of low there. Let me put that together like that. That would be the case on part A here. Let me label this. This would be the left-hand limit. We'll call this the right-hand limit. But the overall limit does not exist, since left-hand limit and right-hand limit increase without bound. Increase without bound. That's kind of the why behind it. All right, and so let's take a look at this graph now. As we approach 0 here, I can see the left side here, the limit of, I'll just put 2 over x cubed, that'd probably be easier. As x approaches 0 from the left side, as we go from the left side, this graph goes down to negative infinity. As we look on the right side of 0, as we get closer and closer to 0, I can see this limit is approaching positive infinity. 2 over x cubed. As x approaches 0 from the right side, the graph or the limit would approach positive infinity. However, the limit of 2 over x cubed as x approaches 0 would not exist. Again, well, this doesn't exist for two separate reasons. First, the left hand and right hand do not equal one another. Secondly, they're increasing and decreasing without bound. Left hand limit, and this would be the right hand limit. So here's DOL number 4.